Getting into the second section of this unit, it seems a little bit overwhelming with the objectives and what we're going to do, but it's so easy and there's so much that you can do in the calculator that it really isn't nearly as much as it seems. So we are going to use rational exponents and switch from radical form to rational exponents and rational exponents to radical form. So that's those first two. We'll evaluate some expressions, which is calculator based, simplify expressions in exponential or radical form, and then we will use exponential equations. We'll write them in log form, and then we'll take log equations and write them in exponential form, and then we'll evaluate, which is also calculator based. So it's really not too bad. So the very first thing that you need to know is the radical versus rational slash exponential. So if you have a radical, you take your exponent of your variables, which would be a 1 right here, and put it over your index. And remember, that's this little invisible 2 that goes here with a square root. So that becomes an x to the 1/2. And then something like this, you take exponent over index, so 4 over 3. This one would be 3 over 4. This would be 2 over 5. So exponent over index every time. Properties of exponents. Now these are all properties that we have done before, but you need to know them. So if you have the same bases, you add your exponents. If you have the same bases and you're dividing, you subtract your exponents. And I'm sorry, if you have the same bases up here and you're multiplying them, then you add your exponents. If you have a base with an exponent and then another exponent, you multiply your exponents. So again, this is just review of things that we have done before, but you have to know it. If you have more than one base raised to an exponent, it's just like distributing that exponent to each one. A negative exponent, it switches where it is in a fraction. So in this case, it's part of a numerator. So to make it positive, we move it to the denominator. Or in this case, it's negative in the denominator. So we move it up and make it the numerator. And anything that's raised to a 0 power is just 1. Okay, so now let's simplify and rewrite expressions using these rational exponents. So this is written as 10 to the 1/4. And so to be able to rewrite that, remember that it's exponent over index. And the index is the number that goes in the radical symbol. So when you go to write out your answer, the 4 goes here, and 10 to the 1st goes here, but we don't write the 1, just not formally. So when we write our final answer, we'll write the 4th root of 10, and this would be our radical form. So this is rational, and this one is radical. Number 2, same base, so we need to add our expressions, or add our rational exponents, so 2/7 plus 3/5. And to be able to add 2/7 to 3/5, we have to have matching denominators. So I'm going to multiply this one by 5 over 5, which is really just 1, and multiply this one by 7 over 7, which is also 1. So I'm changing the way that it looks, but I'm not changing the actual value of it. So we end up getting 10 over 35 plus 21 over 35, and now that our denominators match, we get 31 over 35. So that is what this becomes, a raised to the 31 over 35. So our exponential form, what we're going to write is a to the 31 over 35. But when we write our radical form, remember it's exponent on top, index on bottom. So we're going to put our index of 35 here and a to the 31st power here. So there's 2 different ways to write the answer. Then usually it'll tell you which one it's looking for specifically. Okay, now number 3, we are dividing and they have the same base. So what we do is take our base and our exponents 1/5 and we subtract because it's division. Now when we do 1/5 minus 4/5, the denominators already match and we get a negative 3/5. So we write x negative 3/5. However, we don't want a negative exponent when we write our answer. So let me fix that. There we go. What we're going to do then is give it a positive exponent by moving it to the denominator. And there was no other number here, so we didn't have any number to keep up top, so we just write a 1. So our exponential form we're going to write is 1 over x to the 3/5. And as our radical form, we'll put 1 over, and remember index is the bottom number, so the 5th root of x cubed. Our fourth example here, you'll see that we have all rational exponents, and what I want is one exponential form and one radical form. Well, we need all of those fractions to match. So 1/4 and 1/2 and 9/4. We want them all to have the same denominator. Well, really the only one that needs to change is this one right here. And if we make it 1/4 and we make this one become 2/4 and keep this one as 9/4, what did I get 1/2 from? Holy moly, guys, I'm sorry. 1/4. 3/2 and 9/4. There we go. So we want to all have, so we're going to multiply this by 2 and this by 2 to get 6/4. And then our 9/4. There we are. So what I'm going to do is rewrite this right here to have those exponents that are all the same. So 7 to the 1/4 has not changed, but now x, its power is 6/4, and and y's exponent now is 9/4. Well, you notice that each one is being divided by 4, right? So what we're going to do then is say that we have 7 to the 1st power times x to the 6th power times y to the 9th power, and we're raising that all to the 1/4 power because 4 is the denominator. So when we're writing this in exponential form, we're not going to write the 1 on the 7. It's not formal. It's pretty informal. And we want our formal answers. So 7x to the 6th, y to the 9th, raised to the 1/4 power. Where in radical form, this 4 is our index number. So we have the 4th root of 7x to the 6th, y to the 9th, and this would all be raised to the 1st power, but again, we want formality. We want this to be a formal answer, and so since anything raised to the 1st power is the same as just leaving it, I'm going to rewrite this now without that parentheses and without that 1 there. Now what we have is what's called a logarithm, and a logarithm is just the inverse of exponential equations. And we talked about inverses before and how they work together. You know, division and multiplication are inverses because they undo one another. So if you have an exponent, you can use logs to undo that exponent. Now what we're going to do is rewrite log functions in exponential form. We're going to start there, and then we're going to go backwards. And what I use is called the fishhook method, and actually I had a student teach me this last year who had learned this from another teacher. And what you do is you start at your base here at B, and you go around the equal sign, around the y, and then you stop at your x right there. So what that means is you take b as your base, you raise it to the exponent of y, and you set it equal to x. So whatever number is here, you fishhook around, that's your exponent, you come back, and there's what it's equal to. Now in the opposite form, again, fishhook method, we're going to start with the b, work around to the other side of the equal sign, and then hook onto the y. And so we're going to write log, and we're going to put our b down here as our base, x goes next to it, and then on the other side of the equal sign is the y. So when we go into writing an equation like this and taking it from exponential into log, we use our fishhook. So we start with the number, hook around to the other side of the equal sign, hook back around to the exponent. So we would write log 15 goes down here, 3,375 up here, and set it equal to 3. And this would be exponential form, where this would be log form. So these have exactly the same information. They mean exactly the same thing. They're just written differently. Second one, so start at your base, hook around to your equal sign, and then back up to your exponent. So log 4 is where we started. We went all the way around to the 2 and ended at the 1/2. And number 3, start at 1/5, hook around the 5, and end at 1/3. So log, the base is 125, our number here is 5, and set it equal to 1/3. Easy enough? I think so. And now going from log to exponential. So now starting at your base, hook around to your other number, and then end at this number here. So again, it's a whole hook. So 4 raised to the -4th power equals 1/2. to 56. And that would be your exponential form of this log function. So again, start at 3, hook around the 6, and stop at the 729. So 3 to the 6th power equals 729. And our last example here, I believe this is it. Yep, this is our last one. Start at the 2, hook around to the 3, and stop at the 8. So 2 to the 3rd equals 8. And that is how you do that. And everything else that we're going to do is completely calculator based, so make sure that you have your calculator on you in class so you can learn all of the buttons.